Yeah, so is my screen visible?
Yes, sir, visual.
Fine. Okay, so I was saying something about yeah. So someone was saying regarding the, so you were saying that you have to connect a load resistance which is equal in magnitude to Thevenin resistance, right? Across
Yes.
its terminals A and B. So this will make sure that the maximum power is transferred to this resistor, right? The load resistor that you are putting here, isn't it?
Yes.
Correct. So yeah. So tell me, in that case, what is the power? Maximum power. What is that in that case?
VTH square by 4 RTH.
VTH square by
4 RTH, sir. 4 R Thevenin resistance.
how does that come? Can you just quickly tell
सबसे
me?
यस सर, फर्स्ट वी कैलकुलेट करेंट सर, जो भी थेवनिंग बाई 2
Correct.
आर थेवनिंग।
V
उसके बाद
Thevenin
आई स्क्वायर आर,
I is equal to
उसके बाद
q
आई
to
स्क्वायर,
R Thevenin. Fine.
यस सर,
And then
उसके बाद आई स्क्वायर आर लगा दिए सर, आर थेवनिंग के क्रॉस पावर लॉस आई स्क्वायर
very
है
good.
सर।
So what will be that? One second. Let me write it here. So power to the load is equal
यस,
to I square times R Thevenin,
थेवनिंग।
right? And what is that? VTH square by 4 RTH square into RTH, right? This is gone, so effectively it becomes VTH square by 4 RTH, right? So this is the maximum power that you can deliver to the load. So what is that in this case? So you have V Thevenin equal to, so you have V Thevenin equal to how much? Minus 192 volts, right? And R Thevenin equal to how much? 8
8 किलो ओम।
kilo ohm. So what is power? V Thevenin square upon 4 R Thevenin. What will that be? Again, how did this 10 to power 3 come here? Can you tell me how did this 10 to power 3 come here?
1.152।
No, no, I'm asking why did I write here 10 to the power 3?
Sir, since the resistance was 8 kilo ohm, so
यस,
we
Correct.
have multiplied 10 to the
Right,
power 3.
right, right. Yes, yes. So what is this value?
1.152 आवर्स।
How much? Kilowatts.
यस सर, ओनली वाट सर।
Yeah, correct. Right. So this is the answer. So everyone is comfortable with this answer? This answer that I brought here? Does that anyone have any doubt here? Whatever I did here.
सर, इस मैक्सिमम पावर ट्रांसफर थ्योरम एसी सर्किट में भी हम लगा सकते हैं
Yes.
सेम।
Yeah, yeah. So it is AC circuit, DC circuit. You only need to find out the what is the total Thevenin voltage here and what is the total Thevenin resistance here. After that, you can apply it wherever you want to.
यस।
Correct?
यस।
Yeah. So I guess everything is visible here. So I'm asking that does anyone have any doubt in this question?
नो सर।
Fine,
No, sir.
fine. Okay. After that, I will. Okay. So then, in that case, go back. Stop. Yeah. So I will now. Second. Fine. Yeah. So I will be doing some part, covering some part that was covered in the week 3, and some things that were not, that why I was not able to cover in the last week. So I covered all these things. Yeah. So I briefly talked about this question. So there was a slight error in that in that solution which I did in the last week. The video is uploaded in the YouTube. I would encourage you to you all to find out what was the error that I did. I intentionally did that error with the students. So I was asking the students to tell me what should I do, and I intentionally made that mistake. Since none of you have asked me a question regarding that, I'm assuming you have not seen that video. So I want you to find out what was the wrong that I did in this question. Okay, it is there in last week's YouTube lecture. So you can go through that and tell me what I did wrong here. Okay?
Okay, sir.
Yeah. And next time when I meet with you, you tell me what was wrong. I will ask you this question again, and I want you to answer what I did wrong. After that, I'll move. So anyway, correct answer is 1 volt. What I found out there was not right. I made a mistake deliberately. I went with the students and I saw that no one had any problem there. But so I want you to find out what was it that I did wrong there. The correct answer is 1 volt. I found out a different answer there. So tell me what I did wrong, and then we'll meet. Then we will ask. Then we'll discuss that. Fine. So after that, okay. So I guess you all are comfortable with duality, right? In the week 3, duality was covered.
Yes.
Fine. So can you tell me how will the dual of this network look like?
कैपेसिटर को
One second.
इंडक्टर
One
से
second.
रिप्लेस
One second.
करेंगे.
One second. One second. One second. I will. It will be better if I do this. So all of this is there. So that I have this one. Fine. So this is visible again, right?
Yes.
So this is where I did something wrong here. I did something wrong here. So I want you to find out. So this was the solution that I made last time for that particular question. I did something wrong here. I want you to find out what I did, and then you tell me. Fine. So this is duality. So tell me, what will the dual of this network look like?
कैपेसिटर को इंडक्टर से रिप्लेस करेंगे सर. इंडक्टर को
Okay.
कैपेसिटर से,
But the very first
रेजिस्टेंस
thing,
को
very
कंडक्टेंस के,
yeah,
और
yeah, true.
वोल्टेज
That is true.
सोर्स को करंट से,
That
और
is
करंट
true.
सोर्स को वोल्टेज से.
Everything that you are speaking is true. But I want to ask you first thing what you should do. The first thing is that you should first find out where you will connect all these things that you just mentioned. That is true that capacitor has to be replaced with an inductor has to be replaced with a capacitor, a resistor has to be replaced with a conductance, and all things that you said was true. But I want to ask you, okay, you have all these elements. You have an inductor, you have a capacitor, you have a voltage source, you have a current source. But where will you connect all these things? So first you need to find out how many nodes will be there in the circuit, isn't it?
Yes.
Yeah. So how many nodes will be there in the circuit?
3 सर.
How come?
वोल्टेज सोर्स और कैपेसिटर के पास एक है सर, फिर लाइट साइड में एक
How? Why?
वो तो
No, no. You are
क्योंकि
right. But can you
क्योंकि
give me a
ब्रांच
good convincing
एक
answer?
एक दो या तीन ब्रांच जहाँ कनेक्टेड है सर, उसको एक नोड बोल रहे हैं सर.
नहीं. Okay. So I'm not talking about this nodes. Okay. I'm talking about when you convert this, when you will find out its dual. Okay. In that circuit, how many nodes will be there? You getting my question?
Yes.
Sir, it will be the same.
Yeah. Why? What do you mean by why am I asking this question, by the way? So how many nodes are there? Why am I anyway bothered with this question?
क्योंकि सर्किट को बनाने के लिए बेसिक यही जरूरत है.
Right. So you need to find out where all these things will be connected. So you are right that there will be 3 nodes. Correct. But where they will be? That is my question.
ऐसे भी निकाल सकते L इज इक्वल टू बी प्लस एन माइनस ब्रांच नोड और रूट से देखते मेश से.
Okay. So basically, yeah. So basically, okay. So when you find out the dual of a circuit, you make the dual of each and everything. Okay. So you right now what you said was that a dual of voltage source will be a current source. Dual of this capacitor will be a inductor. An inductor. This thing will be replaced by a conductance. This thing will be replaced by a voltage source. This here will be replaced by a capacitor. But other than that, these loops, these meshes, they will also be transformed. Okay, they will also be converted into their dual form. So there are three independent independent meshes, isn't it? So you should have three independent nodes also, isn't it?
जितने इंडिपेंडेंट मैच होंगे उतना ही नोट्स होंगे.
Right.
Yes.
So this was already covered in the lecture, in the week's lecture. So if you have any doubt, go back and watch those lectures. So this was covered. So there are the number of independent nodes in the circuit, in the dual circuit, will be equal to the number of independent meshes that you will see in this whole circuit, right? So there are three independent meshes. So you should have three independent nodes, isn't it?
Yes.
Correct. Now you are now tell me. So let's say that this loop is taken care of, is replaced by this node. So let me call this loop as 1, and let me call this loop this node as 1. Fine. Now this mesh, suppose this is designated as 2, so I'll call this as 2. So these are dual of each other. Now this loop is this mesh is covered by 3, so I'll call this as 3. Okay.
Yes.
By the way, there will be always a reference point. Okay, you should always have a reference point. There will always be a reference point. So all these
रेफरेंस
nodes,
पॉइंट तो लेते हुए तो 4 नोट हो जाएंगे सर.
no, reference point is not part of that node. It is a separate. How will I say? So all these voltages, these nodes will be.
We are
Yeah, tell me.
रेफरेंस नोड को हम लोग ग्राउंड कर देते हैं, दैट्स व्हाई वी आर नॉट कंसीडरिंग इट.
Correct. Right.
सर तो
Right.
अगर ड्युअलिटी को छोड़ दें इस सर्किट को देखा जाए तो अगर कोई पूछेगा कि कितने नोट्स हैं तो 3 नोट्स होंगे सर.
नहीं, 4 होंगे. I mean,
4.
if you have to consider that there is always a reference, you have to take care of that. Basically, you have to ignore that reference, and then you have to say how many nodes are there. So that is what I meant. Is the same?
रेफरेंस को छोड़कर 2 नोट्स है इस सर्किट में.
No, no. Uh, Other than references, there will be as many number of nodes as there are independent number of meshes. That is what I am saying.
हाँ तो ड्युअलिटी के लिए ना सर, लेकिन हम ड्युअलिटी का भी बात मतलब थोड़ा स्किप करना चाह रहे हैं, मतलब थोड़ा सा उसके लिए
अच्छा, okay.
उसको ड्युअलिटी को छोड़कर ऐसे देखा जाए सर्किट में तो 3 नोट्स है ना सर.
नहीं, there are 4 nodes.
कैसे सर?
This is also a node here.
यस वन कॉमन नोड.
So that is what I am saying. Here also there is a common node. Okay.
यस.
Okay, fine. So let me mark it here. Okay, now what I should do? Tell me. This is the 10 volt voltage source between in this which is a part of only this loop, only this mesh, right? Mesh number 1. So this has to be replaced by a 10 ampere current source between this node and the reference node, isn't it?
यस.
You remember what I am saying? So basically, now you have to replace every element with its dual, and you have to also check that is it a part of only that particular mesh, or is it a part of two or more meshes, and accordingly you have to decide where you have to connect it. So since it is part of only this mesh here, so in the hence I will be I will be confident enough to say that this its dual element, which is a current source, should only be a part of this particular node and the reference node. Since we are not considering reference node as a node, so this particular current source should only be present, only be associated with this particular node, isn't it? Because this particular voltage source was only a part of this particular mesh, right? And since you are taking the dual of that, hence the current source that you will replace it with will be also associated with only that particular node, which is corresponding of that particular mesh. Are you following what I am saying here?
यस.
Right. So in this case, you have to replace it by 10 ampere current source. So what will be the direction of that 10 ampere current source? Tell me.
above node
Correct.
and
Right.
indirect है.
Right. Right. Fine. Now tell me what happens to this 2 farad thing. But first,
It is between mesh one and mesh two के
let
बीच
us
में.
let us do an easy thing here. What happens to this 3 ampere current source?
3 और रेफरेंस के बीच में वोल्टेज सोर्स होगा.
Correct. Fine.
पोलैरिटी ऊपर प्लस और नीचे माइनस है
Galat.
क्योंकि करंट ऊपर एंटर कर रहा है. ऊपर प्लस होगा.
No, it will be like this.
राइट दिस.
Yes. You see the direction of this. So you have to also consider this particular convention here. So this current is opposite to this convention. The
It
voltage source will be
is
opposite to
because
here.
of the direction of current in the third mesh.
Right. So the current that you have chosen here, the current, this thing, the mesh, the current convention that you have chosen here is
The mesh
opposite to,
current is.
yeah, is
Uh,
opposite to the current source here, isn't it? So that is why you have to change the sign here also. Am I
यस
clear?
सर.
Fine.
कि
Fine. Now tell me what happens to this 5 Henry thing here, this particular thing. Tell me.
2 और रेफरेंस के बीच में से डायरेक्ट
Very good.
कैपेसिटी.
Very, very good. What will be the value? 5 farad, isn't it?
यस.
Now tell me what happens to this 2 farad and this 20 ohms.
1 और 2 नोड के बीच में इंडक्टर लग जाएगा सर.
Very,
2
very good.
हेनरी.
Which is equal to 2 Henry, right?
यस.
What happens to this 20 ohms?
2 और 3 के बीच में कंडक्टेंस 1/20.
No, it will be only 20.
1.
No, no, it is 20. The values will be always same. Only the what do you say? The
nature changes.
nature
Value
changes,
doesn't
correct?
change.
Yeah, definitely, yes. So the nature changes, but the value does not change. The nature changes from a resistor to a conductor, right? Conductance, resistance to conductance. So notice the symbol that I have made here. This is the symbol of ohms. This is the symbol of mhos, right? Ohm inverse.
Yes.
So magnitude does not change, the nature changes. Fine. So this is the dual, isn't it?
Yes.
Fine. So let us now check whether we are right or not. Fine. So I will be sharing that part. 1 second. Yeah. So see what it is. What did we say? So you had doubt what regarding this, right? So you see the sign here is inversed, isn't it?
Yes.
Correct. Now also see the 10 ampere current source is moving up. So this is anyway you said was correct. You see also everything is according to the thing that we have that we did. So I guess you have no doubt here, right?
Yes.
Fine. Moving ahead. Okay. So so a different question. Source transformation, right? Okay. Yeah. So this question I wanted to attend with source transformation also. Yeah. So I would like to cover that here. Uh, so you do not have any other engagements right now, right? I guess you are all set now. You do not have any other classes now. Do you have? Hello. Do you have any other classes?
Yes.
No,
So
sir.
what is the time?
7 PM से एक और.
6:56.
Okay, it's 7 p.m.
यस, एक और मेरा क्लास है,
There
another
was
class.
another session at 7 p.m. sir.
Okay, okay. Okay, in that case, I think we'll have to leave now. So I'm very, very sorry for the inconvenience caused today. So I don't know what happened. So last time
Sir,
also
can we join in the 7 p.m. session?
7 p.m. session. So that is taken
Yes.
by another student. Okay, another tutor. So he will be taking that
Oh,
session. So
actually, you are not taking that. Actually, you are only in this session.
yeah, I only a part of
That's
6 to 7, not beyond that. So anyway, don't worry about it. Okay, so these things will be posted on YouTube, so you can go through that, and I will try to cover these things in the next tutorial. Okay, join there. I will cover these
okay,
things
sure.
in the next tutorial.
In the same time, sir. 5 to 6.
No, no,
I
it's
mean six
six
to
to seven.
seven.
Yeah, yeah, 6 to 7. The next tutorial that will be held on when next Monday, right? There I will be taking,
Okay.
and I will make sure that
Okay.
these small things that happened today should not happen again next time. Sorry for the laptop. My
It's okay,
laptop
sir.
got crashed suddenly. I'm very sorry for that. Okay, fine, fine. Okay, enjoy
Okay.
your class. Next
Bye, sir.
class. Bye bye.
Thank you, sir.